I am Jonathan William and I present conic selection. Introduction the AC of all which in the cycle and the equation of the cycle is x squared plus a squared equals r squared. That is to say, there are all these points of the plane that if you add the squares of their coordinate, it gives you a fixed number that is a constant number, and that is r squared. And this can be seen in the way, let's say that here I have my x. So I am going to write the cycle. This cycle, the property that it should speak is that it has a fixed radio. That is are all these corresponding points that we do and their coordinate square. This number square and this cycle formula come out of the design formula, and this design formula is simple and it's extension of what the Pythagorean theorem is at these points. X, A are points on the planes indicated from 0, 0. The same I how I calculate a distance square, because if I took the root of the is the formula of the distance, we square and it gives us a certain distance square. So is my 0 square is simple x square, and we add a my 0 square, which is y square, and this is the distance square. So this formula for the distance we have here is nothing more than the Pythagorean theorem expressed with coordinate. For example, we consider this circle x squared plus a squared equals 9 as a gram, and this I simply put my x, and this tells me the origin. Here we have a 3 minus 3 minus 3, and any other distance that measured from the origin measure 3 The 9 is the radius square. The radius without the square we do 3. And it cannot be minus 3. Cannot be minus 3 because we are talking away, and this introduction the AC of O. Our cycle is a geometric shape and is not of much use the algebra. Seeing the equation of the cycle isn't function, but you may need to work with cycle equation. In your algebra class, in private term, a cycle is the shape form in the sand by drawing a stick the center in the sand, putting a loop of the string around the center point. The loop told with another stick and dragging the second stick through the sand and the further extent of the loop of a string. The resultant figure drawn in the sand is a cycle. In algebra terms, a cycle is the set of loops of points x, y. Some fixed distance r from some fixed points h, q. The value of r is called the radius of the cycle, and the points h, q is called the center of the cycle. The general equation of the cycle is x squared plus y squared plus dx plus ey plus f equals 0. And the center radius form of the equation is x minus h squared plus y minus q squared
and no problem with me.
equals r squared. Where the h and the q come from the center points h, q, and the r squared come from the radius value r if the center is the origin. So h, q equals 0, 0. The equation simplifies to x squared plus y squared equals r squared.
My name is Jose Ruiz. I'm talk about parabola. The parabola is the locus of the points on the plane that are equidistant from fixed point called focus and a fixed line called directrix. Element of the parabola. Focus is the fixed point F. Director. It is the fixed line D. Parameter is the distance from the focus to the directrix. It is designated by the letter P. 4. Axis. It is the line perpendicular to the directrix that passes through the focus. 5. Vertex is the interaction point of the parabola with its axis. Number 6. Radio vector. It's a segment that joins any point of the parabola with the focus. History. Throughout the history of mathematics, concepts have been more important than the terminology used. However, the inflated Apollonius of the conical section is of great importance than usual. In the past, they were referred to by common way they had been discovered. Section of the sharp cone, section of the rectangular cone, and section of the obtuse coconut. Archimedes continued to use these names, although it's the same that I also already used the name of parabola as a synonym. For a section of rectangle cone, however, it was Apollonius, possibly following the advice of Archimedes, who first spoke or named the conic section shoes as ellipse and hyperbola. The names given were not new, but adapted from the early use, possibly obtained from the Pythagoreans as the solution of quadratic equation by the method of application of areas. A standard equation of the parabola with vertex and the origin. A standard equation of the parabola that open to the right or the left. J2 equal for ax, where a equal 0. Vertex v equal 0, 0. Focus f equal a, 0. Guideline x equal less a. Horizontal axis j equal 0. Straight side for a. A standard equation of the parabola that opens up or down. X2 equal for aj, where a equals 0. Vertex v equal 0, 0. Focus equal 0, a. Guideline j equal less 0, less a. Horizontal axis x equals 0. Straight side for a. How to graph and solve a parabola. To get a parabola, we will use the equation that we have marked. Is j equal x squared less 6x plus 9. After we write down the values of the a, b, and c to find the point of the vertex of the parabola, we will use the following formula. And a equal 1, b equal less 6, c equal 9. The formula is x equal less b between 2a equal less for less 6 between 2 for 1. X equal 6 between 2 equal 3. It is vertex. We substitute the letters and solve it. Now that we know that x is equal to 3, we use the first formula to get the values of the j. Now, we move on the Substitute the x for 3 and solve it. The formula is j equal x squared less 6x plus 9. J equal 3 for 2 less 6 for 3 plus 9. J equal 9 less 18 plus 9. J is equal 0 vertex. And as we see, the value of the j is 0, and that is the vertex of the parabola. Then we repeat the same producer in the h empty space in the table. Once we have exacted all the values, we go to graph. We can see the points and x1 j4, x2 j1, x3 j0, x4 j1, and finally x5 and j4. And our parable is ready, and I'm done. And we realize that it is a positive parable.
I am Pedro Valdelozano, and I am to talk about hyperbola. In mathematics, a hyperbola, plural hyperbolas or hyperbolae, is a type of smooth curve lying in a plane, defined by its geometric properties or by equations for which it is the solution set. A hyperbola has two pieces called conics, components or branches, that are mirror image of each other and resemble two infinite bows. The hyperbola is one of the three kinds of conic section formed by the intersection of a plane and a double cone. If the plane intersects both halves of the double cone but does not pass through the apex of the cones, then the conic is a hyperbola. Hyperbolas arise in many ways, as the curve representing the function in the Cartesian plane, as the path followed by the shadow of the tip of a sundial, as the shape of an open orbit, as distinct from a closed elliptical orbit such as the orbit of a spacecraft during a gravity-assisted swing by of a planet, or more generally any spacecraft exceeding the escape velocity of the nearest planet. Sorry. As the path of a single apparition comet, one traveling too fast ever return to the solar system. As the scattering trajectory of a subatomic particle acted on a birepulsive instead of attractive forces, but the principle is the same. In radio navigation, when the difference between distances to 2 points but not the distances themselves can be determined, and so on. Each branch of the hyperbola has two arms which become straighter, lower curvature, further out from the center of the hyperbola, diagonally opposite arms, one from each branch, tend in the limit in a common line, called the asymptote of those two arms. So there are two asymptotes whose intersection is at the center of symmetry of the hyperbola, which can be thought of as the mirror point about which each branch reflects from the other branch in the case of the curve. The asymptotes are the two coordinate axes. Hyperbolas share many of the ellipses' analytical properties such as the eccentricity, focus, and the directrix. Typically, the correspondence can be made with nothing more than a change of sign in some of them. Now, I will talk a little bit of history. The word hyperbola derives from the Greek, or excessive, from which the English term hyperbola also derives. Hyperbolae were discovered by Menaechmus in his investigation from the problem of doubling the cube, but were then called by Menaechmus in his investigations of the problem of doubling the cube, but were then called sections of obtuse cones. The term hyperbola is delivered to have been coined by Apollonius. Sections of obtuse cones. The term hyperbola is delivered to be coined Apollonius of Perga in his definitive work on the conic sections. The conics, the names of the other two general conic sections, the ellipse and the parabola, derive from the corresponding Greek words from efficient and applied. All, all three names are borrowed from earlier Pythagorean terminology, which referred to a comparison of the side of rectangles of fixed area with a given line segment. The rectangle could be applied to the segment, meaning have an equal length, be shorter than the segment of exit the segment. Hyperbola general equation. The general equation of a hyperbola is as follows. Ax squared minus cy squared plus dx plus ey plus f equal to 0. If the coefficient display style a and display c are or of different things, not null and display style a. Demonstration. In the equations, the variables in display style x and display style y are separated and commenting display style a and display style c into common factors. By completing squares, the previous equation is written as. Now the trinomials in the left become markable binomials. Hyperbola general equation. Convert the term of the right to constant named display style according to the value of display style t. The following cases are presented. If display style t2 larger than 0, the transverse and focal axes of the curve are parallel or collinear to the displaystyle x-axis. If the displaystyle smaller than 0, displaystyle t smaller than 0, the transverse and focal axes of the curve are parallel or collinear to the displaystyle y-axis. If displaystyle t equal to 0, displaystyle to t equal to 0, the equation represents two lines that intersect. Whatever the case, the center of the hyperbola or the point of intersection of the two lines is always equations in polar coordinates. Hyperbola open from right to left. Hyperbola open from top to bottom. Open hyperbola from northeast to southwest. Hyperbola with origin in the right focus. Hyperbola with origin in the left focus.
I am Ismael Tamayo and I will present you conic ellipse. First, we will see the properties of the ellipse. Center a point inside the ellipse, which is the midpoint of the line segment linked the two foci. Major minor axis, the longest and shortest diameters of the ellipse. Semi-major, semi-minor axis, the distance from the center to the forehead and closest point on the ellipse. Foci, 3 points that defines the ellipse. Short and line segment linking any 2 points on ellipse. Tangent, a line passing at the ellipse and touching it at just 1 point. Second, a line that intersects an ellipse at 2 points. How to solve the equation above graphic. This equation is the basic form, is the easier for me to do, and again you can know what the ellipse will be like. As the x and the y is squared are unknown, you can know on the point 0, 0. The equation show you the 25 and 16. For to solve that, only need solve the square root on the 25 and 16, and this is equal to semi-major and semi-minor axis. With that we can know the major and minor axis. Only we know the foci, and for that we can use the Pythagoras theorem. How you can see the answer is 3. That means the foci is n 3 negative and 3. B is in the y, while A is in the X, so the ellipse, then the ellipse would do like this. Now I will do an example to show how it's done. First I need to know what is A and what is B. A is greater than B. Then A is 9. And B is 4. You have to remove the square root of the 2 to have the semi-major and semi-minor. And since we have put, we can obtain the foci that is made with the Pythagorean theorem. Now the C is 2 dot 2. Okay, now I need to graph 3 is here. Oh, I is in the line. I is in this line. The ellipse to this line to The ellipse